Again. So in this video, we're going to look at a third style of doing this problem. And so let me just you get this a little bit clear here. So this was the first approach of using this idea of using the do block, and maybe this is very imperative style of programming. And the second approach was basically we used the idea that my IO is a functor and an applicative functor, and by knowing that we actually wrote some code out. We wrote some code out which is over here, and we also tried this out on my on the Haskell shell. And I highly encourage you to visit the last video just to get a little bit more familiar by how I was able to exploit the fmap and the applicative functor ideas to do the same problem. But now I'm going to use a little bit more of an intuitive approach where I feel actually it's more it has uh, at least I feel is more applicable in the sense that, look, what I really have with me is this two ideas. So what I'm going to do is I just need some space here. So let me just erase part of the board here. So you know what, I think I can get rid of these things here. I already have them in the last video. So if you really need to revisit, you can go back to my last video and just get yourself a little bit more familiar with what I did in there. But I think it's nice just if I can get a little bit of cleaner slate in this video. Okay, so what I really have is this thing. Okay, look, this is the outside world. Okay, this is the outside world. Okay, this is the outside world. And when I say outside world, I really mean things that are impure. Okay, so I'm talking about the impurity aspect here. Okay, where I could be having IO set of operations or some monadic values, some side effect, and these are my impurity aspect here. And here I have my pure world. Okay, this is completely pure, where there are no side effects and everything is nice and clean. And in the pure world, I have this method. I have this method plus plus. Okay, I have this method plus plus here. Now, what's the type of plus plus here? Well, the generic type of plus plus using polymorphic types is basically the type of plus plus is that is basically a method that takes in a list of some A's here, and it takes in some list of A's and gives you back some list of A's here. But just in this context where I'm just playing with this problem where I'm trying to concatenate two strings, I'm just going to rewrite this a little bit differently. Where I'm going to say, okay, look, I have now a list of chars here. Okay, because I'm just trying to be very specific to this example here, and I have a list of chars here. Okay, and that gives you back a list of char. Okay, I'm just trying to perform a concatenation here. Now, again, if I have to use the type synonym, I can actually even rewrite this as takes in some string, takes in a second string, and gives you back a concatenation of the two strings. So this is basically the idea with the plus plus operator. Okay, now what is really happening here is that, look, in order to make my program a little bit more useful, instead of hard coding these strings here and showing you, oh look, I can do a concatenation of my two strings here, I would like to get these two strings from the outside world. I would like to get it from the outside world, but I'm going to ask the user that, look, enter string 1, enter string 2, and just perform a concatenation. Maybe that's a little bit more useful than having these two strings hard coded and playing with the plus plus operator. But then the question is, the moment I'm going to get things from the outside world, look, if I'm going to ask the user that enter a string and enter two strings, and I'll then perform a concatenation, the whole idea of asking a user is basically I'm going to perform some set of IO. I have a side effect. I have a side effect that there's going to be some set of input output going to be happening at this point where I'm going to be dealing with impure values, or in other words, I'm going to be dealing with monadic values. Okay, and when I say monadic values, I don't have any more something of type string, but what I now have is something of type IO string here. Okay, so my actual string, right, the moment I try to get the string from the user, this is something that I'm trying to get from the user. But as I get that from the user, I'm going to introduce a side effect. I'm going to introduce a side effect of this IO. Okay, so what can I do at this point? What I can do at this point is I can actually take my plus plus operator, okay, which is basically this the signature of the plus plus operator is that, look, I have a string and you give me a second string. Okay, you give me two strings here, and what I'm going to do back is going to give you back the concatenation of those two strings here. This is what the plus plus does. what I'm trying to do is I'm trying to lift this method. I just want to use this idea that, look, even before getting formally into lift at this point, I'm trying to say, okay, look, I'm trying to take this method that belongs in this domain, in this purity aspect here, and somehow make it work with things that are actually impure, right? So take this method. Okay, let's say if I had this magic function, let's call this kind of this yellow box here, which takes in this pure function. Okay, I feed this pure function into this yellow box, and what comes out as an output is something of the following kind: IO string, IO string, and giving you back an IO string. Okay, so this yellow box, what it does is it says, okay, look, I'm going to take this piece, okay, and I'm going to give you back this entire thing over here. Okay, and this is really great for me, because what I can do is I can take this method, which is my lift method, feed it into this yellow box, and out comes back this another specialized method that can now work with these monadic values without me doing any heavy lifting here. So I'm going to say, okay, the name to this box over here, the name to this box over here is basically the lift method, and again, because this lift method is being worked on two parameters, and what it's going to give you back is some monadic value. The idea here is actually lift m2, okay, where m is basically the monad, and 2 here is just an indicator that I'm going to be playing with two of these input arguments here. Okay, so can I then say, I'm just going to write my code as follows. I'm going to say lift m2, and I'm going to pass in this plus plus operator. Okay, this entire thing, the type of this entire thing is going to be an IO string to an IO string, giving back finally as an IO string. Okay, if that's the type, if this is the type of this entire thing, meaning this is an actual method that takes in these two IO strings here, then all the thing that I need to do at this point is provide in those two IO strings. Remember, the type of this entire thing, is this entire piece right here. That's the type, meaning that this is a method that takes in two IO strings. How do I provide in two IO strings here? Let's just pass in getLine. Okay, getLine, the type of getLine is an IO string, and again pass in getLine because that's another IO string, and the complete type of this entire thing is going to be an IO string. Okay, so let's just try this out. Let's just try this out on the Haskell's shell. So on the Haskell's shell, okay, what I'm going to do now is I'm just going to revisit my concatenate binding, the concatenate binding that I worked on my last video. But now I'm not going to use the applicative or the functor style, but I'm just going to make use of my lift m2 method. So first thing, let's do a lift m2. Okay, I'm going to lift my method, which is my concatenation method, the plus plus thing, and I'm going to pass in getLine, and I need to, of course, did I not in scope lift m2? So I need to import my, let's just see if I forget, I might be forgetting my, the lift m2 is part of the control.monad. Okay, it's part of the control.monad module. So let's just import control.monad. Okay, excellent. Let's just go back over here and then let's try this out. Okay, so let concatenate and lift m2 plus plus getLine. Let's just check the type of concatenate. The type of concatenate is an IO of char. Excellent. This is what was expected. I wanted an IO char there. And then finally, I'm just going to do at this point, let's just try this code out. Let's just run our let binding concatenate. Okay, there's the first string. Let's enter Abbas. Then let's enter Academy. And I should get back the concatenation of Abbas and Academy. So I hope you found this useful. We just played with a very trivial example, but I wanted to show you three different styles that could be applicable in this context, because I was able to make use of the imperative style of programming, which was using the do block, and then we looked at the idea of using a functor and the applicative functor, because IO is an instance of the IO type class. IO is an instance of the functors type class, excuse me, and IO is an instance of the applicative functors type class as well. And then the third style was using the lift m2 method. And anyways, I hope you found this a little bit useful in your quest of getting better in Haskell and having fun with Haskell.